All right, Gen Chem people, we are now going to move on from ionic compounds to covalent compounds. Now, let's recap ionic compounds just a little bit. Now, remember, ionic compounds are compounds. Compounds are pure substances that are made of ions. We have a positive ion that is usually a metal, and we have a negative ion that is usually a nonmetal. Okay, remember, ionic compounds are formed because we transfer electrons from the metal to the nonmetal. That's how we create the ions. So if we lose the electrons from the metal becomes positively charged. And we gain electrons on the nonmetal becomes negatively charged. And the charge differential, positives attract negatives. So the charge differential between the positive metal and the negative nonmetal causes those two atoms to attract each other. And we call that an electrostatic charge. It's kind of like little magnets holding things together. Today, we are going to talk about molecular substances. And molecular substances are held together by a different kind of bond. They're held together by covalent bonds. So let's discuss what a covalent bond is and how it is different from ionic. Okay, so I'm asking you to recall that ionic compounds, the electrons are transferred. The electrons are transferred from a metal to a nonmetal. And when I transfer those electrons, the metal becomes a positive ion and the nonmetal becomes a negative ion. Molecular bonds don't work that way. Molecular or covalent bonds, we form covalent bonds. Oh my gosh, that really didn't want to do that. Let's try that again. Now I want to break down this word covalent. Let's think of things that start with the prefix co. Cooperation, coordination, things like that. Co means with or together. So if I have co, and then valent is coming from our valence electrons. So if I'm saying a covalent bond, I am sharing electrons between two atoms. So these bonds are the result of shared electrons. And by shared electrons, I mean those electrons that are shared actually orbit both nuclei of the atoms that are sharing those electrons. So the electrons orbit both atoms. Okay? In this class, we are only going to worry about naming binary covalent compounds. Now, in Latin, bi, or Greek also, bi means two. So we are going to be doing things that are only made of two different types of atoms. Now, molecular compounds actually make up most of the things in this world, and they're extremely complex. But we're going to just do the simple ones that are just made out of two different types of atoms or two elements. So just two elements at a time. So example, the first one. This is two hydrogens with oxygen. Hopefully you already know the common name for it. The common name for this is water. But if we want to do the scientific name for it, we are going to call this dihydrogen monoxide. Okay? Hopefully you are seeing some words that you know mean numbers. Let's do this next one. We have nitrogen and three fluorines. We would call this nitrogen trifluoride. Nitrogen trifluoride. And then this last one, CH4, one carbon and four hydrogens. We would call this carbon tetrahydride. This does have a common name. The common name in terms of chemistry, this is methane. You guys know this as natural gas. So this is the primary gas in natural gas that we burn for our heating in the winter when we have our furnaces going. Okay, so when we name molecular compounds, notice we have the same pattern. Sometimes we have a prefix, but if we only have one, we don't have a prefix. So this prefix is there if there's two or more of the first element. And we will use Greek prefixes, and then we use the name of the first nonmetal. And then we have a prefix that tells us the number. We have a number prefix here that tells us the number of atoms of the second nonmetal. But notice we don't use the full name of the second nonmetal. We use the root of that nonmetal name, and we add on the suffix "-ide". So these also end in "-ide", just like our binary ionic compounds do. They end in "-ide". Now, these boxes here that are our number prefixes, they are given to us by Greek prefixes. These Greek prefixes tell us the amount of atoms that we have of both of these nonmetals. So let's look at these Greek prefixes. You are going to need to memorize these, so please memorize these. Okay, so let's go over these. Mono means one, and a lot of times mono will be shortened to mon. Di means two. Tri means three. Tetra means four, and this is where it differs from the Latin. We're used to quad being four. That's Latin. This is Greek, so Greek is tetra. Penta for five, which is different than quintes, which is the Latin. Hexa is 6, hepta is 7, octa is 8, nona is 10, and nona is 9, and deca is 10. That is all you're going to have to know, just the first 10. We are not going to go above 10. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. That's what you need to know. Okay? We are going to name and write formulas for some of these compounds. It's pretty simple. Once you get the pattern, you'll be like, oh, I get this. It's not that hard. Okay, so we're going to try a few here. We're going to name the following compounds. We have one nitrogen. Now remember, when we have one of the first nonmetal, we do not put a mono here. We just name that first nonmetal. So this is going to be, wow. This is going to be nitrogen. And then I've got 3 hydrogens here. So remember the prefix for 3 was tri. So we're going to put the prefix tri and then hydrogen. The root of hydrogen is hide. And then we're going to add on ide. So hydride. Okay. This next one, we have 1 carbon. So we're not going to put a mono or a di because if there's only one, we just start off with the element. Carbon. And then I've got 4. The Greek prefix for 4 is tetra. And then once again, we have hydrogen. So the root of hydrogen is high. And then we're going to add on dried. Okay? This commonly is called methane. Okay? Now, on water, we actually do have 2 of our first element. So we can call this dihydrogen. And then we only have one water. So this is going to be mon, or one oxide. Now, we want to put the mono and then oxide. Notice that gives us two O's in a row. We don't need that second O. So we get rid of it. So we actually write it like this: dihydrogen monoxide. So this is one where we shorten the mono to mon. This, of course, is better known as water. Okay? Now, a while ago, there was a petition floating around the internet to ban dihydrogen monoxide because, it kills people. It causes a lot of damage. Think about floods, hurricanes, rain, storms. People do drown in swimming pools and in lakes and rivers when they swim. And it just goes to show you that there are a lot of people that don't understand science, because when they put the scientific name for water, dihydrogen monoxide, down there, it kind of sounds scary, doesn't it? It's really just water. So if you understand how to name things in scientific terms, hopefully you won't be able to be fooled. They got over 100,000 signatures on that petition a couple years ago over the internet. Now, I would really, really like to see somebody try and live without water, because honestly, it can't be done. Our bodies don't work without water. So that was kind of entertaining to see that floating around the internet in a very sad way. It made me feel like a science teacher, like I had not done my job, that so many people were falling for that. Okay, this next one, we have two nitrogens. We're going to start with dinitrogen. And we have one oxygen, monoxide. Okay. Let's see. We've got two nitrogens once again. So we're going to start with dinitrogen. And here we have 5 oxygens. So the root for 5 is pentaoxide. Now, once again, we have 2 vowels in a row here. We can get rid of that A if you want. If you want to keep that A, you can keep it as well. So we can write it as this: dinitrogen pentoxide. I should have put a space in there. That needs to have a space. That's my fault there. Okay, I want you to try these next couple. Pause the video. Okay, you ready to try and see how you did? So we have phosphorus, and we only have one. So phosphorus, and we have 3, so trifluoride. Notice spelling is going to be important on this, so make sure you are spelling these elements correctly. Xe is xenon, and we've got 4, so we're going to do the root tetra, and then we have fluorine. The root of fluorine is fluor, and then we're going to add on ide, xenon tetrafluoride. Okay, next one. Right? We've got 2 dichlorine monoxide. Okay. We've got 1 sulfur, so we're going to just start with sulfur. We've got 2 oxygens, so dioxide. So what do you think this one's going to be? Did you say sulfur trioxide? All right. Hopefully you're feeling pretty comfortable about this. So notice we have a number prefix and then the non-metal. Then we have another number prefix, and this first number prefix is only if there's 2 or more. If there's only one, we don't put a mono in there. And then we have our second number prefix. And then we have the root of the nonmetal. And then we add on the suffix "ide." That is how we name these things. Okay? So let's see if we can do it the opposite way. If I give you the name, can you give me the formula? Let's try that. So sulfur doesn't have a prefix in front of it giving us a number, so that we know if there's no prefix, there's only one of them. So we know there's only one sulfur. And then hexa. Hexa means, did you say 6? Hopefully you said 6. We have 6. Fluoride is fluorine. So we have 6 fluorines. Here we do have a prefix. We had di, 2, and we have hydrogen. So dihydrogen. Di is another number, so we've got 2 of them. Oxide is oxygen. Dihydrogen dioxide, this is also commonly known as hydrogen peroxide. Okay, dihydrogen dioxide is hydrogen peroxide. Silicon, we have no prefix, so I know that I have one silicon. And then di, 2, and oxide is oxygen, so 2 oxygen, silicon dioxide. Okay, this is the basis for glass. So this is what glass is basically made out of. Carbon tetrachloride. So 1 carbon, what does tetra mean? Did you say 4? What is chloride from? Hopefully you said chlorine. So 1 carbon and 4 chlorines. We have no prefix here, so we only have 1 nitrogen. Di, we have 2, and oxide is the root of oxygen. So nitrogen dioxide. Once again, no prefix here, but we have a prefix here, tri, and then we have iodide. Iodide, that is the root of iodine. So nitrogen triiodide. Okay, here we do have a prefix, di, meaning 2, right? 2 carbons. Hexa is 6, and then hydride, that is the root of hydrogen. Yeah. Okay. C2H6 is otherwise known as ethane. Ethane is the common name here. Phosphorus pentachloride. So we don't have a prefix, but we know that we have 1 phosphorus. Penta is 5. Chloride comes from chlorine. PCl5. All right, how are you feeling so far? Okay, chlorine trifluoride. Chlorine, we don't have any prefix here. And then tri means 3, and fluoride is from fluorine. Okay, how'd you do on those? Okay, I want you to pause the video and try this first section by yourself. Take a minute, fill that out, and then come back and we'll check, okay? All right, nitrogen trifluoride. Did you come up with NF3? Nitrogen monoxide. Did you come up with NO? Nitrogen dioxide. Did you come up with NO2? Dinitrogen tetraoxide. Did you come up with N2O4? Dinitrogen monoxide. Did you come up with N2O? Okay, phosphorus trichloride. Did you come up with PCl3? Phosphorus pentachloride. Did you come up with PCl5? Sulfur hexafluoride. Did you come up with SF6? Disulfur decafluoride. Did you come up with S2F10? And xenon tetrafluoride. Did you come up with XE? F4. All right, how did you guys do? All right, this next section, I also want you to take a minute, pause the video, and see if you can do this on your own. We'll check in a minute. Okay, you ready to check in? All right, CCl4. So I have one carbon, so I can start out with carbon. I don't need to have a prefix here. Carbon, and I have 4 chlorines. So I'm going to start with tetra, and chlorine is going to shorten to chloride. Carbon tetrachloride. How'd you do on that one? I've got 4 phosphorus. So I need to start out with my Greek prefix, meaning 4, which is tetra, phosphorus. And then I have 10 oxygens. 10 is deca, oxide. Now, if you want to, you don't have to have that A. You can get rid of that A if you want and just have tetra, phosphorus, decoxide as well. All right, we got 1 chlorine, so chlorine. And I've got 3, so 3 is tri, and this is fluorine, so fluoride. Chlorine trifluoride. Okay, B, boron. And I've got 3, so tri, and chlorine shortens to chlor, and we'll put on ide, boron trichloride. Sulfur, and then I've got 4. 4 is tetra, and then fluorine, the root is fluor, and then I'll put on ide, sulfur tetrafluoride. This next one, 1 hydrogen, and then bromine shortens to bromide, hydrogen bromide. 2 nitrogens, dinitrogen. And then I have 4 fluorines, so tetra, fluoride, dinitrogen tetrafluoride. 1 xenon, and then I have 3, so tri, and then fluorine, fluoride. 1 phosphorus, and then I have 3, so tri, and then iodide. I need to put another D in there. Okay, sulfur, dichloride. How'd you do on those? Guys doing okay? Now this next section is a little bit more challenging because I have mixed up ionic compounds with covalent compounds. So the first thing you have to do is look at that first element and decide, is that first element a metal? If it's a metal, you're going to use your ionic compound naming. But if that first metal is a nonmetal, if it's a nonmetal, you're going to use your covalent compound naming rules. Okay, so you might want to take a minute to go back and review your ionic compound naming rules, and then take a minute and go through this and see how you do. I'll pause the video and we'll check in just a minute. Okay, let's look at this first one. Hydrogen is a nonmetal, so we are going to use our covalent naming rules. So we are going to call this hydrogen chloride. Okay. Phosphorus is also a nonmetal, so we are going to use our covalent naming rules. So we are going to call this phosphorus pentachloride. Okay. Potassium here is a metal, so we are going to use our ionic naming rules. So this, we don't put numbers in. Remember, unless it's a transition metal and we put numbers with Roman numerals. So we don't have to put a di here. This is just going to be potassium sulfide. Okay. This nickel is a metal. It's also a transition metal. So what we need to do is we need to figure out SO4. It's got a polyatomic ion. Remember using our polyatomics? If you remember, if we look up our polyatomics on our polyatomic chart, SO4 was sulfate and it had a -2 charge. And because nickel is a transition metal, we have to put a Roman numeral in designating the charge for that metal. So if sulfate is a -2 charge, that means nickel has to be a +2 charge to have the whole thing add up to 0. So we're going to call this nickel, Roman numerals 2 sulfate. Okay. Chlorine is a nonmetal, so we're going to use our covalent naming rules. So we're going to call this chlorine. We've got 3 trifluoride. Okay, oxygen is also a nonmetal, so we're going to use our covalent naming rules. So oxygen difluoride. Oops, that needs to be U. Let's change that out. Difluoride. Okay, aluminum here is a metal. It's part of our transition metal group, but it's one of the few transition metals that has a set charge. Aluminum is always a +3, and because it's always a +3, we do not need to put a Roman numeral here. We have to also look up OH. If we look up our OH, it is called hydroxide. So we are going to call this aluminum hydroxide. Okay? Aluminum hydroxide. All right, nitrogen is a nonmetal, so we're going to use our covalent naming rules. So nitrogen trichloride. Okay, we've got 2 polyatomics here that we need to look up. The first one, if you remember, NH4 was called ammonium. So we're going to just put the name of the polyatomic, ammonium. And the last one, PO4, was phosphate. So phosphate. Ammonium phosphate. Non-metals, so we're going to use covalent. So disulfur, dichloride. All right, let's look at this next side. Carbon dioxide, definitely covalent. 1 carbon, right? I have no prefix, but I do have a prefix here, 2 for my oxygens. Ammonium carbonate. Those are both polyatomics that I need to look up on my polyatomic chart. I also need to look up their charge. So let's look up my polyatomic chart really quick. Do I have my polyatomic chart? Let's do this. Honors chemistry. And we need to look up our periodic table with our ions. So let's look up our ions really quickly. So ammonium has a +1 charge, it's NH4, and carbonate has a -2 charge, it's CO3 -2. So those are the two ions that we need to be working with. So ammonium why does it keep switching on me? Ammonium, oh my goodness. NH4 plus and CO3 -2. Now remember, we have to balance the charges. So if I have a +1 and a -2, that means I'm going to need 2 of these. So I'm going to need to put my parentheses around the ammonium and give myself 2 of those to balance out the -2 charge on the carbonate. Okay, ammonium carbonate. Sulfur, I don't have a prefix, dichloride, so 2 chlorines. Calcium, ooh, that's a metal. Calcium is an alkaline earth metal, so it will acquire a +2 charge. Okay, so it's right here. It's in that second column. So that, remember, is a +2 charge. And then the other ion there was iodide, which is right here, and it will acquire a -1 charge. So let's balance out those charges. Calcium is a +2, iodine is a -1. So in order for the charges to balance, I'm going to need 1 calcium and I'm going to need 2 iodines. So 1 calcium and 2 iodines. Okay, boron, I only need 1, and 3 of those 3 fluorides. Phosphorus, I only need 1. Triiodide, so 3 iodides. Magnesium, ooh, magnesium. Let's look at magnesium. Magnesium is right here. It is also a +2 charge. Okay, and then when we look at that perchlorate, ooh, that's one of our polyatomics. So let's look at perchlorate. Here we go. Perchlorate. ClO4 -1. So let's work with that. So magnesium is a +2. Perchlorate is ClO4 -1. Okay, how am I going to balance those charges so that the overall charge becomes 0? I'm going to need 1 magnesium and I'm going to need 2 perchlorates. So MgClO4 2. Okay, potassium. Potassium is a metal as well. And we have permanganate that we're going to be using. So permanganate is MnO4 -1. And potassium is in the very first column. So it is a +1 charge. So let's look at those. Potassium is a +1. Permanganate is MnO4 -1. So to balance a +1 and a -1, I only need 1 of each. KMnO4. Okay. Aluminum. Aluminum is always a +3 charge. And phosphate. We already did phosphate over here. Phosphate is PO4 and it's a -3 charge. Okay. So in order to balance those, I'm going to need one of each. Positive 3 plus a negative 3 adds up to 0. So aluminum phosphate. And last but not least, dioxygen. I've got 2 oxygens. And difluoride, I've got 2 fluorines. How did you guys do? Okay, so next time we are going to go over and review all the things that we've learned since the beginning of second quarter. And we are going to get ready for our midterm for right before Thanksgiving. Have a great day. We'll see you later. Bye.